Good evening, students. I'm back. You're also back. So, welcome to Dimansha's class. We are going to start class 10's first chapter in mathematics. And the chapter which we will be starting, before that, I would take you back to class 6. Yes, it is required. Just we have to recap. Don't you see the recap on the TV serials before the current series, the serial starts? Don't the TV serials take you back to the previous things that happened in the previous episode? So here also I would take you back to the previous episodes in our previous class, what we learned. Okay. So, before I start, I would request you, maybe I'm going back to class 6, but definitely I'll come back to class 10. There will be something new to learn also. So, don't skip this video. You must watch it from the very beginning to the end. Otherwise, a very important thing you will miss out. Of course, it will be a total video will be on the basis of recapitulation. So, I would request you to see this video and you will enjoy. I hope so. And if you enjoy, definitely you will be liking this video. And if you like, don't forget to press the like button, bell button, and don't forget to share this video to your friends so that they can also learn about it and they can also go back to class 6 and come back to class 10 after they remember all those things which they have learned in the previous classes. Okay? And finally, I would request you to press the subscribe button. Okay? Now, let us start a sum. Yes, HCF and LCM. Yes, you remember now, we have done it in class 6. Even to some extent we have done some in class 5 also. But class 6 will be better. That is why I'm taking you to class 6. So let us learn about the HCF and LCM. Why? Because in class 5, those HCFs and LCMs were very easy. So I don't want you to make the class so easy as because you are in class 10. So let us start from class 6 only. So now, first example which we will be doing, example 1, find the HCF and LCM of three numbers, 60, 84 and 108. So we will stick to a method that is prime factorization. Though we know that it can be done in various methods, means in division method also. But first we will be sticking to prime factorization method only. So what are those numbers? 60, 84 and 108. Isn't it? So now, 230, there we were always told by our teachers that always start prime factorization with the smallest number. Even though we know that this could be divided by 30 or 10 or something like that, I would tell you, no, you start with the smallest prime number and continue with the smallest only. If suppose here, let me show you first, 2 15s are. Now it doesn't go by 2. So 5 it goes, but before 5 it is 3. Why? 15 is divisible by 3 also. So 15 is divisible by 3 and 5. So out of 3 and 5, 3 is smaller. So stick to smaller for the first. 3 5s are 15. Okay. Now 5 ones are 5. As soon as you remember, as soon as you get 1, this part is over. The same thing, 2, 4, 2, 2, 2, 1. See here, it goes by 3 as well as 7. 3 is smaller than 7, stick to 3. 7s are 21, 7, 1. We got 1, it is finished. Now 2, it is even number, goes by 2. It also goes by 3, but 2 is smaller than 3. So we will go for 2. 2 is smaller than 3. 2 5s are 10, 2 4s are 8. Then 2 2s are 4, 2 7s are 14. Now it goes by 9 as well as 3. But 3 is smaller than 9, so we will go to 3. 3 9s are 27 and 3 3s are 9. 3 1s are 3. We got 1, so it is finished. Now what we have to do, then write 60 is equal to 2 2 3 5 1. 2 2 3 5 1. Next, don't ignore 1 also. Okay? It will help you. Why I am telling you? Now 84 is equal to. Now always remember, you must write the digit under the same digit. See, it is 2. Write 2 under this 2. First 2. You could have written 2 here also, but no. If there is another 2, then write under this 2. Yes, there is another 2. Write this 2 here. Now 3 into 3 under 3. Then 7. Is there any 7, sir? No, sir. So throw it out. 7. 1. Yes, 1 under 1. Clear? Then 108. 108 is equal to 2 2 3 3 3 1. 2 under 2. 2 under 2. 3. First 3 under 3. Now 3. 2 more 3s are there. There are no 3s here. Throw them out. 3. 3 and then 1. Okay, students. Now let us move on to HCF. HCF means here we will have to see those prime numbers that are present in all the 3 numbers. Suppose you may say, sir, suppose there are such a number, there is such a prime number that is present in 2, but third one it is not there. No, that will not be accepted. You have to see how many numbers are given in the question. 3. So in that case, while choosing the prime number, you must see, while finding the HCF of those 3 numbers, the prime numbers which you are choosing must be present in all 3 numbers. Those numbers only will be chosen while finding the HCF. So see here 2 is present in all the 3. This 2 under the 2 present in all the 3. This 3 is also present under the 3. It means present in all the 3. So write down under 3. Now 5 is not in all 3. It is only in 1. Into 1. Don't write 5. Then 7 is only in 1. 3 is only in 1. 3 is only in 1. So write down equal to outside. Now 1 3s are 3 2s are 6. 6 2s are 12. So 12 is the highest common factor that divides 60, 84, 108. So 12 5s are 60, 12 7s are 84, 12 9s are 108. Okay. So HCF we have got. Now let's move on to LCM. Now in case of LCM the case is different. In LCM, whatever the numbers we have got collectively, each row, each column should be written. See, forget this HCF now. Forget this HCF now. Ignore this. Now see, for this column 2 into, for this column 2 into, for this column 3 into, for this 5, even if it is 1, write down 5 into, for this column 1, even if it is 1 7, write 7 into 3 into 3 means here all the columns have to be taken into account. So now while multiplying, in shortcut I would recommend you to leave this 5 and 2 separate. It means 2 5s are 10. So 3 3s are 9, 3s are 27, 27 2s are 54, 54 7 in graph you can do. Let me tell you again. 3 3s are 9, leave 7. 3 3s are 9, 3s are 27, 2s are 54. 54, if you can directly you can do, it's okay, otherwise you do it. 7 4s are 28, 35, 37. 378. Because to 378. Yeah, sir. You have not taken into account this 2 and 5? Simple. Because that is why we kept 2 and 5 separate. So here we got We were asked find the HCF and LCM of these three numbers. We got HCF 12, LCM 3780. Clear, students? Remember, we have done the same thing in class 6, isn't it? Yes. Now, pause the video, copy it down. So, students, now see. Use Euclid's algorithm to find the HCF of 408 and 1032. See, here also I would say, sir, something new we are getting maybe in class 10, Euclid's algorithm. It's a new term. But, my dear students, the sum which we are going to do is also known to us. This also we have done in class 6. How? I'll show you. See, in the previous example, in example 1, what we did? We followed prime factorization method to find the HCF of the given three numbers. 60, 84 and 108. Now, we will not follow prime factorization method. We will follow, yes, division method. So how to do this? Yes, we remember, we have done in class 6. Same thing. See, I'll do it in the right hand side. See, which one is the smaller one? 408 will become the divisor and 1032 is the dividend. Okay. Now, what will it be? In the rough you see, 402 it is 10. That it definitely goes by 2 only. 2 8s are 16, 2 4s are 8. If it goes by 3, if we do multiply by 3, it will become 3 4s are 12. 1200, which will become more than 1032. So automatically we will choose 2. So 2 8s are 16, 2 4s are 8. 6 plus 6, 12, carry 1, 2, 1, it plus 2, 1, 6. Yes. Now what to do? Correct. This remainder becomes the new divisor and the previous divisor now becomes the dividend. Sir, like this we'll have to continue, but there should be an end. Yes, till we get the remainder 0. We will have to continue. Now, see here, 216 into 2 it becomes 432. It becomes more. So it will be 1, 2, 1, 6. 6 plus 2, 8. 1 plus 9, 10, 1, 192 is the remainder. So, this becomes the divisor and the previous divisor becomes the dividend. 216. Now, 192, 4, 9 plus 2, 11. Now, 192, 24 becomes the divisor and its previous remainder divisor becomes the dividend. Now, 3, no, not 3, 2 8s are 16. 8 4s are 32, 8. 8 4s are 32, carry 3, 8 2s are 16, 19. Yes, my dear students. Now we got the remainder 0. So therefore, as per our previous knowledge, 24 is going to be the HCF of this of these two numbers, both these numbers. HCF will be 24. Clear, students? Now, sir, so what's the use? Where is Euclid's algorithm? Why we have done this? To bring you from known to unknown. See, now what we are going to do here, 1032 is equal to, we know, what do we know? We know that dividend is equal to divisor into quotient plus remainder, isn't it? So, 408 into 2 plus 216. In our Euclid's division lemma, what we saw, A is equal to, what was it? BQ plus R in our previous video. If you have not seen, please go back. I would recommend you to go back to that video, see that, understand that, and then come to this. Now see here, A means the quotient, means dividend. B is the divisor. Q is the quotient plus smaller is the remainder. Same concept is applied. Divisor into quotient plus remainder. Same thing, first step. Now second, what happens? This 408 becomes the previous divisor becomes the dividend. So it is dividend is equal to dividend is equal to divisor 216 into quotient is 1. Quotient is 1 plus what is the remainder? Remainder is 192. Okay. Next, this 216, which was the previous divisor, becomes the dividend. 216 has gone inside. 216 is equal to 192 into 1 plus 24. 192 into quotient is 1 plus remainder is 24. Clear? Now, this 192 again becomes the dividend is equal to this dividend equals to 24 into 8. 24 into 8 plus 0. So, the step where you are getting the remainder 0, that steps divisor is the HCF. So, here you will say therefore HCF is equal to 24. Answer. Got it, students? That's it. Only this much. If you can do directly, this you can do through the rough. You can do the rough and do it directly. Or if you are having lack of confidence, do this. Maybe this one only you do it in the rough, and seeing this, you put this. This is called as Euclid's algorithm. Clear, students? Now pause it and copy it down. Okay, students. Now see what are we asked to do? Find the HCF and LCM of 612 and 1314. So let us go. In prime factorization method only it will be convenient because the numbers are very small. We can do it in prime factorization method. So 612 and 1314. If the number becomes bigger, go for straight cut, go for division method of HCF. Okay. Now 2 3s are 0 6. 2 1s are 2 5s are 2 3s are 3 5 1. 3 1s are 3 7s are 21. 17 is a prime number, so 17 1s are. It goes by 2 2 6s are 12. 2 5s are 10. 2 7s are 14. It doesn't go by 2. Does it go by 3? Let us check out. For that, rule of 3 is 7 plus 5, 12 plus 6, 18. 18 is divisible by 3, so 657 is also divisible by 3. 3 2s are 6, 3 1s are 3, 9s are 27. Let us check up whether it goes by 3 or not. 9 plus 1, 10, 10 plus 2, 12. 12 is divisible by 3, so it goes by 3 again. 3 7s are 21, 3 3s are 9. Now students, 73 is an odd number, so 73 1 ja 73. Now see, 612 is equal to 2 into 2 into 3 into 3 into 17 into 1. Okay, now 1314 is equal to 2 under 2. Don't write this 2 under this 2. Always prefer the first one, left hand side number. Okay, then 3 into 3 under 3. Again 3 under 3. Next 73 into 73 outside because there is no 73 on top. So 1 into 1. So what is the HCF? Is equal to. Now how many numbers are given in the question? 2 numbers. Now finding the HCF, we have to choose those prime numbers that are present in both the numbers in the question. See, which are given in the question. So 2 present in both. 3 present in both. This 3 present in both. This 1 present in both. 17 is present in only one. And this 73 is also present in only one. Okay. So now equals to HCF will be 3 3s are 9 2s are 18. Okay, now LCM. LCM in this case we have to take all the columns. Okay. So forget HCF. This line you will forget. So for 2, 2. For this 2, 2. For this 3, 3. For this 3, 3. For this 17, 1, 73. There is no 5, so we have to do the full calculation here. So 3 3s are 9 2s are 18 2s are 36. So 73 into 36. Let us do 36 first. Otherwise we may forget. 6 3s are 18, 6 7s are 42, 43. 3 3s are 9, 3 7s are 21. 8, 9 plus 3, 12, carry 1, 5, 6, 2. Now 17 remains into 17. Those who don't remember the table of 17, for them I am doing 7 8 is 56, carry 5, 7 is 14, 19, carry 1. 7 is 42, 43, carry 4, 7 is 14, 18. Then 8, 2, 6, 2, 6, 9 plus 8, 17, carry 1, 6, 14, 3, 4. It is equal to 4, 4, 6, 7, 6. So, we got the HCF as well as LCF. Now, our answer is over. Now we are moving on to next topic with the help of this example. See, we must remember something here. Product of two numbers is equal to their HCF into their LCM. Sir, this also we have done in classes. Right. So, product of two numbers. What are those two numbers? You must see 612 into 1314. These are the numbers which are given to us, of which we had to find the HCF and LCM. So, product of two numbers, those two numbers which are given in the question, is equal to their HCF. How much is HCF? 18. Into their LCM, that means into LCM is 4, 4, 6, 7, 6. So that means the left hand side should be equal to the right hand side. Isn't it? So LHS must be equal to RHS. So now let us see whether it is correct or not. LHS. So LHS means 1314, 1314 into 612. 612. 2 4s are 8, 2 1s are 2, 2 3s are 6, 2 1s are 2. 4 1 3 1. 6 4s are 24, 6 1s are 6, 7, 8. 6 3s are 18, carry 1, 6 1s are 7. 8, 6, 11, 14, 9 plus 1, 10, 8. Let me check up once again. 8. 2 plus 4, 6. 6 plus 4, 10 plus 1, 11, carry 1, 4, 10, 14, carry 1, 9 plus 1, 10, carry 1, 8. So it is LHS is equal to 8041, 8041, 68. Now let us see RHS. RHS means 44676. 44676 into 18. So see, those who don't know the table of 18, for them I am doing this way. 8 6 are 48, carry 4, 8 7 are 56, 60, carry 6, 8 6 are 48, 54, carry 5, 8 4s are 32, 37, carry 3, 8 4s are 32, 35. 6, 7, 6, 4, 4, 8, 6, 7 plus 4, 11, carry 1, 7 plus 7, 14, carry 1, 10, carry 1, 8, is equal to 804168. 804168. See students, are they tallying? They're tallying. Aren't they? Yes, they are telling. So we can say that product of two numbers is equal to their HCF into their LCM. Clear, students? Sure. Pause the video and copy it. So the students, you see, here the question is, two tanks contain, actually I missed out this word, two tanks contain 504 and 735 liter of milk respectively. There are two tanks. Both the tanks have their specific capacity that is stored. Find the maximum capacity of container which can measure the milk of either tank an exact number of times. Means both the tanks are filled up with milk. Now I need a mug, suppose. Now what should be the maximum capacity of the mug so that I pour out the milk from the first tank? 1, 2, 3, 4, like this, till the tank is empty. Okay. Similarly, with the same mug, I'll pour out the milk from the second tank also. And the point is, the number of times I have taken out the milk from the first tank with the mug, and the same mug, that same number of times I will be taking out the milk from the second tank. For that, what should be the maximum size of the mug which I will use for taking out the milk from both the tanks, but in equal number of times? So maximum, the word maximum itself tells us, maximum, this word maximum itself tells us, find out the HCF. What is the full form of HCF? Highest common factor, means highest, maximum, largest, longest, tallest, means you are going towards the upper side, higher side, longer side, maximum side. Clear? So we have to find the HCF here. HCF of 504 and 735. We will apply what? Now Euclid's division algorithm. The smaller number 504, bigger number 735, you can apply the division method directly or algorithm method also, because it is not asked which method to apply. You can apply your own method. 1's a 504, 1, 3, 2, 504. This divisor now becomes the dividend and this remainder becomes the divisor now. 2's a 2 1's are 2, 2 3's are 6, 2 2's are 4, 2, 4. Now this remainder becomes the divisor and this divisor becomes the dividend. 42, 4, 6 are 24, 4 5's are, let us take 5. 5 2's are 10, carry 1, 5 4's are 20, 21. 1, 2. Now this remainder becomes the divisor and the previous divisor becomes the dividend. 42, 21, 2's are 42, remainder is 0. So therefore, find a maximum capacity. Maximum capacity is equal to how much? What is the HCF? 21. 21. And that is the answer. Clear, students? Pause it. Copy it down. Now students, for example 5, I am not wasting time in writing the question. I am just dictating the question, and this question of course will come into your screen. You can pause it and you can copy it down. I am just reading the question. After you write it down, please keep the question in front of you so that when I am reading, you can concentrate in the question. Ravi and Shikha drive around a circular sports field. Of course, they are driving a sports field. They are driving their cars, of course, in the sports field. There are tracks drawn there. Ravi takes 16 minutes to take one round, and Shikha completes the round in 20 minutes. So Ravi in 16 minutes and Shikha in 20 minutes. One is little fast and the other one is comparatively slow. If both start from the same point and at the same time they start, they are standing side by side. The referee says start. They start from the same place at the same time. One is slower, completes the round in 20 minutes, and the other one is faster, completes the round in 16 minutes. So the question is, when they are going to come and meet, suppose the one who is going slowly, and the other one is going faster, will move fast, when I'll again come back and join the slower one. So that is the question. When are they going to come and meet at the starting point all together? They are telling, and go in the same direction. After how much time will they meet at the starting point? Again they will come. Means until and unless they meet together, they will not stop. They will continue. 16 minutes continues, Ravi continues, Shikha also continues. The time will come when they will find that they are at the starting point both together. And that is asked, how much time it will take for both of them to come and meet at the starting point together. Am I clear? So for that, what do we have to find? We have to find the least time they will take to come and meet. Not the maximum time. तब तो हो गया, साल भर, उम्र भर they will continue. So there is no end of the maximum. So here we have to assume that how much less time they will take to meet again. Clear, students? So least time they will take means, what do we need to do? Correct. Least, lowest, smallest, lowest, common, multiple. Got it now? Maximum, highest, greatest, longest, HCF. Least, lowest, minimum, shortest, thinnest, whatever term you use for the lower side will be lowest common multiple, means lowest. So here, what do we need to find? LCM of 16 minutes and 20 minutes. So let us find out 16 minutes and 20 minutes. There's another method you also know. No, let it be as because I'm sticking to one method, so let me stick to that simple method itself. 2 8s are, 2 4s are, 2 2s are, 2 1s are, 2 10s are, 2 5s are, 5 1s are. So 16 2 1, 20 2 5 1. So it's LCM, not HCF. Don't confuse here. HCF. If it was HCF, we should have taken 2, this 2, and this one, nothing else. But we are asked LCM, so we have to take all the colors. 2 1 5 is equal to, leave this 5 and 2. 2 2s are 4, 2s are 8 is equal to 80 minutes is equal to 60 minutes plus 20 minutes. That means 1 hour 20 minutes. After 1 hour 20 minutes drive, continuous drive by both of them, they will find themselves, means after they have started, the referee said start, they started, one is traveling at 16, completing the circle in 16 minutes, other one in 20 minutes. They are continuing for 1 hour 20 minutes constantly, and finally they will find at an average speed. Again I tell you, average speed, no one is increasing or decreasing the speed. So they will find themselves after 1 hour 20 minutes drive on the same field at a constant speed, that they are on the same starting point. Clear? Did you like it? Then please reward me. Press the like button, share this video with your friends, press the bell button, and don't forget to subscribe. So let's meet in the next video. Thank you. Good night.